Welcome to solverfy.
In this problem, we have a one-dimensional infinite potential well that has an electron. So let's draw a one-dimensional potential well which has an electron E. Now we need to show that for very large values of n, where n stands for the state or the energy state, the difference between the adjacent energy levels. So imagine that we have one energy level as En, and the another energy level will be the next adjacent one, En plus 1. We need to show that E adjacent, let's call it delta E adjacent over En is equal to 2 over n as n tends to a large number. So let's evaluate this. The energy level En for an electron in a one-dimensional infinite potential is given as n square h square over 8 ml square. So I can find the adjacent energy difference, which is delta E adjacent this is adjacent, in this case h square over 8 ml square. This is a constant value, so all we need to take note is now n plus 1 and n level. So this gives me n plus 1 whole square minus n square. So thus delta E over E, we can express this number as you will see, this factor gets cancelled out and we just get an n plus 1 whole square minus n square and another n square in the denominator. Now n plus 1 square can be opened up as n square plus 1 plus 2n, and we have an n square with a negative sign divided by an n square. This becomes equal to 1 plus 2n over n square. Now if the value of n is very large, 1 plus 2n can be written simply equal to 2n over n square, and now you can see that this becomes equal to 2 over n. So we have shown that as n increases, the difference in energy between the adjacent levels with respect to the energy of a level keeps reducing as n increases. We move to the next page. Now we need to show that as n tends to infinity, whether delta E or delta E over E approach 0. We already saw that delta E over E, which is equal to 2 over n, will actually tend to 0 as n tends to infinity. So this directly solves part D for us. As far as B and C are concerned, we first need to show whether delta E tends to 0. Now we can open this part and see what delta E is. Delta E is this. So as n increases, delta E does not tend to 0 because delta E depends upon 1 plus 2n, and as n tends to infinity, this delta E value actually increases to infinity. So the answer for B should be that delta E does not tend to 0. So does not tend to 0. Similarly, we can also see that since E is directly proportional to n square, as n tends to infinity, this does not tend to 0. Now we have the question that what do these results mean for correspondence principle? It importantly means that as n increases, the difference, the relative difference, this is a relative difference between the energy levels, keeps reducing and becomes 0. So what we actually get is a continuum. So if we start with n equal to 1, n equal to 2, then we get n equal to 3, and as we go to higher and higher orders, this difference keeps reducing. 4, 5, this is 6, then it's 7, and up till some higher values. After that, they all merge into each other because the relative difference between them is small. This means the correspondence principle.